everyone. Welcome back to Cracking the GRE Math Subject Test, Calculus 2. We are on question number 23. And in this question, we're asked to find the minimum distance from the origin to the curve 3x squared plus 4xy plus 3y squared equals 20. And in this question, the distance, what they're actually asking us is to minimize the distance function. And just to make our life a little bit easier, we can maximize the square of the distance function. Let's call it big D, which is x squared plus y squared. So we want to minimize this. Minimize. So this is an optimization problem. And if the constraint that we were given was not so complicated, if it was something simpler, like something that we could solve for x or for y, then we could just plug in the constraint into one of these variables and then minimize d just like in calculus 1. But in this case, we're going to have to use Lagrange, the Lagrange multipliers method. So I'll just remind you how to do that. What we're going to do is take the gradient of d, the gradient vector, and set it equal to lambda times the gradient of g of xy, where g of xy is this function right here. Okay, I'll write that. We'll call this g of xy. The 3x squared plus 4xy plus 3y squared is g of xy. And this is equal to 20. That's our constraint. So we're going to use this, we're going to set these two equal to each other and use that to find x and y. So let's take the gradient of d. That's going to be the vector 2x comma 2y. Remember, derivative with respect to x, derivative with respect to y. And this is going to equal lambda times, now what's the derivative of g with respect to x? That's going to be 6x plus 4y, and the derivative with respect to y is going to be 6y plus 4x. Alright, the next step is to set each of these elements equal to each other. In other words, 2x is equal to lambda times 6x plus 4y, and 2y is going to equal lambda times 6y plus 4x. So let's write that. 2x is equal to lambda times 6x plus 4y, and 2y is equal to lambda times 6y. I'm going to write it like this, 4x plus 6y. Okay, and the reason I'm going to write it that way is so that we can subtract. Let's subtract the second equation from the first equation, and we will get 2x minus 2y, I'm just going to write 2 times x minus y, is equal to lambda times, I'm going to factor out a 2 from here as well. Well, this will get us 2x minus 2y, but let's just factor out a 2, and we'll get 2 times x minus y. Okay, the 2's cancel out. Let's cancel out these 2's. And we get x minus y equals lambda times x minus y. So what does that mean? Well, if x minus y does not equal 0, then lambda can equal 1 because we can cancel out the x minus y from both sides. But if x minus y does equal 0, then we get that x equals y. Alright, so what happens if lambda equals 1? Let's see. If lambda equals 1, then let's plug that into one of these equations. Then we get 2x is equal to 6x plus 4y. Well, let's see. That means that 6 minus 2, that's 4x equals negative 4y, which means that x is equal to negative y. So actually the two possibilities are that either x equals y, or x equals negative y. Now we have to check each of these possibilities and see what we get. Well, if x equals y, let's do the first case, x equals y. Then let's plug that into our constraint. Then we'll get 3x squared plus 4x times x, that's plus 4x squared, plus 3y squared, that's going to be plus 3x squared, equals 20. Which means that 3 plus 4 plus 3, that gives us 10x squared equals 20, or x squared equals 2, which means that x is equal to plus or minus root 2, and in that case y will also equal plus or minus root 2, because remember we said that x is equal to y, so this is going to equal plus or minus root 2. Okay, so this is one set of options that we'll have to check. The other possibility we said is that x equals negative y, so let's check that one. If x equals negative y, let's again plug that into our constraint g. Then we get 3x squared. Now instead of plus 4x squared, we're going to have minus 4x squared, and then plus 3x squared, all equals 20. So 3 minus 4 is negative 1, plus 3 makes 2. X squared equals 20, which means that x squared is equal to 20 divided by 2, which is 10. So that gives us that x is equal to plus or minus root 10, which means that y is equal to, remember y is, x equals negative y, so y equals negative x. So if x is positive root 10, y is going to be negative root 10. And if x is negative root 10, then y is going to be positive root 10. So like that. Okay, so we have four possibilities here, these plus or minus root 2s and the plus or minus root 10s, and we have to see which of these gives us the smallest distance. Remember, our distance function, the function that we're trying to minimize, is d equals x squared plus y squared. This is actually the distance squared function. If we find the minimum big D, we'll have to take the square root, because they're actually asking us for the minimum distance, not the minimum distance squared. So let's plug these in. So big D of root 2, and actually it doesn't matter if you take plus or minus root 2, because we're squaring each of them anyway, is going to be 2 plus 2, which is 4. And big D of root 10, plus or minus, again it doesn't matter, and minus plus root 10, because you're squaring each of them, so that gives us 10 plus 10, which is 20. So we can see that actually the root 2 solutions are the ones that give us the smaller distance, and so that means that the minimum distance from the origin is going to be the square root of big D, 4, which is 2. So our answer is C.